Bear with me, guys. While I do this. I think Steve, you deserve a better video reply. So I'm driving down the road. I've got you on I'm leaning over towards the dash on my cell phone, it's supported on the dash. So bear with me as I focus on driving also. To summarize this timeline, correct me if I err. Pool deck collapse with puncture. Okay. Probably due to saltwater flooding. Alright, so it's interesting, the word flooding. So flooding can mean, it does not necessarily, your word flooding has two meanings. One means it's over it, it's soaking it, it's bathing in it. Flooding also means like you flood something to rejection. You standing water, it's flooded right now. So do we blame the salt water for that? Well, there is, water can get behind tile, that grout and things like that is not impervious to water getting behind tile. The deck, though, as I understand it, was and I don't know what PSI they use, a stamped concrete and a combination of pavers. I think the pavers are around the pool area and then the rest is stamped concrete. I could be wrong. It looks like the lamination took place after the collapse, and I'm biased on this part. I show a section in one of my videos, one of my thumbnails, where I think it began right around column 28 and between the column closest to the building. That's where the fracture is. I would love for people to find me, do some heavy lifting here and find me the cracks or the injections. Might be a good indication of where the cracks are. So the injections, the engineer shoots down. If we can find the images, location of that, that's where my new bias would position to, where the injections are, considering that those were the only cracks that required some type of repair, and that's the way they went at it. Now that injection, I don't think a contractor came out there on his own and just said, I think we can just do epoxy here. I think just like this current report, there's a report that exists. So talking to the news lady there, because only one news lady with brains here, it's apparently, she should find that report where someone said and paid for epoxy injection. That's going to be very telling on what was downsized in the repair, perhaps what they did, and this property probably has video of that repair. Maybe, it's a long time to maintain video, but maybe, who knows? Maybe the contractor has it. Maybe there's some emails between the contractor and the association. Emails on the contractor side might be private, but the association, they might release it. It's still a private company. With that said, if they were structural repairs, the city would have to be involved to sign off, either through the engineer that would sign off on it or themselves signing off on this repair. So it all ties in. Now, let me get back to your question here. And deterioration, its connections overloaded with extra pavers. All right, so I got to get off this damn exit. It's backed up. So think about it as a bridge. You can reduce the load values of a bridge, the load capabilities of a bridge, based on its weakest member that could cause a collapse. So not the railing, for example. The railings are just the railings. You might lose some federal highway money on that, but the railings are just the railings. So if they collapse, they just break apart, then railings don't count. So the weakest structural member. In this deck, our weakest structural member would be the steel. So it would reduce its load capabilities. So yes, at one point, maybe it was capable of holding the extra layer of pavers and overlay. That's pretty huge. I would really think I'm reaching to say that it was capable of that. I don't think it was ever capable of that, seeing where the reinforcement was located and how it failed. And I don't see this lap length going on. When we see it ripped out, if you notice what's lacking here, so to the reporter, lap length matters. If you want to go after the municipality, you can go after them on this. As it ripped out one side, what should be left? Think about that, guys. What should be left if it would lap length existed, meaning the overlapped rebar? If it ripped out one side, where is the other side's reinforcement coming across to meet this side of the tear out? I don't see it. I don't see any lap length so far in the images. It seems like it's almost like they use that rebar like a dowel system from one side to the next, and I don't see it going over to one side of the building to the next side of the building ultimately, or from one beam to the next beam. I don't see that. If you see the rip outs, you'll see that they sort of stop mid-span of these decks, of the collapsed sections. So it's lacking lap length as far as I can see. In other words, you tear out one side of it, we see that, well, the other side should be staying in place. We should be seeing at the ends, at the tips, we should be seeing about 30 inches or so, depending on the size of the rebar, the way the engineer spec'd it. I'm an old school specker like that myself, 30 times the diameter of the bar. So, and I triggered the guy in Louisiana, the engineer in Louisiana was triggered by that, and yet it was also spec'd 30 times at the Hard Rock Hotel collapse. So people are still using it. He demanded that I was wrong, and I must use this other form to determine lap length. Obviously, just because he found the source that says you must use it that way doesn't mean it's true. Pool deck collapse brings down car ramp. Okay, so the car ramp did not fail. I believe the car ramp is solid from the base up. They just infilled it and then put concrete on top of it. Even though we see that exposed rebar, that's just the reinforcement of the ramp, concrete ramp. I do not believe it's a suspension deck, if you will. That it's a bridge deck going. The ramp is acting like a bridge deck. No, I think it's on grade, filled in, and that's what you're looking at there. So no, the image, the video I showed, that I believe is the deck, the end of the deck you see that's fallen down, and or it could be one of the internal rooms there that, as the deck pulled down, it pulled out, somehow transferred over and pulled out. The internal room dropped. Why would I say that? The guy said he heard something crash below him that could have been from, he's on the first floor, he is in the front, it could have simply been the deck collapsing. He did make it out. He didn't say his floor fell from underneath of him. Also keep in mind the elevation changes from the pool deck to the first floor appears to be about 8 inches or so. I think I got that wrong earlier when I said, I think it's 9 to 3. So it's, I think I said 8, and I think it's about 7 inches. But it's less now that they added the extra cover from the original plans. It would be less. It might be 1-to-1 almost. You might have like a 1-inch step down to go from there into the building. I don't know. I don't know how that cover, how they resolve the cover, the concrete cover along with the pavers, pavers and stamped concrete. I did see before the collapse, the image, the pavers appear to be on an angle from the deck, going back towards the building. So it's not going into the pool. They don't want water runoff from the rain filling into the pool, obviously. I think that's their intent. But they then direct water back towards the building, not to the coping of the coping of the pool, which you wouldn't want that surface water to run into the pool, right? But then you'd want some through the roof drains would have been awesome. Some surface drains, they could have drilled those through and made some connections and resolved the water that way. And they could have did that a long time ago when they installed the concrete layer along with the pavers. They could have addressed that water issue. Again, if you look at the architectural plans, he addressed that on the roof. He zoned that roof so beautiful. I cannot imagine he made a mistake and made a level deck that would hold water down on the first level. Now, interesting, if you got a good deck, why the F would you cover it with stamped concrete and pavers? Well, maybe you want a different look. But that's a lot of weight, a dead load that you're going to put on there. Dead loads for you guys mean it's a permanent load. And now that would have to be, the structure would have to be strong enough to take this new permanent load. So the calculations, some engineer would have to have done it back then. Shit. I'm just making it past this fucking pole. Okay, good. There was a pole broken, and I was driving, and you see the guys looking at the broken pole, the power line pole, course, there's some cables up there holding it. It fractured with the repair. Those little damn splints they put on them. That would have been a great video to show you why I don't like those splints. Because you can see a fracture right at the splint. Damn it. I'm turning around. I'm going to turn around and videotape that. And then I'm going to post that later. So, why I don't like those splints. I've been wanting to do a video on these splints for some time. I've got multiple data on it, but I do not have one of these. And so, where the splint fractured, it was the theoretical fracture in my mind, and now it's 100% a proven fracture. Let's see what else you got here. So, you reduce the load capability of it, is what it would come down to. That would be compression testing and testing that steel. Going down to the steel, looking at the dimensions of it and its location, and then reevaluating the spans. Each span is a little bit different. All right, so I'm not going to read the rest of your comment because I want to load this up and get this image, this video right. Well, I still can before they start. No, they're nowhere near moving this pole yet. Yes, they are. It's just starting to bring up the machine. All right, I got to go, guys. Let's see how I end this. Come on, end video. Yeah.